Hello, chemists. We're going to talk about stoichiometry this morning. Uh, you might be asking yourself, what is stoichiometry? Well, it's using a balanced chemical equation to determine how much reactant or product is consumed or produced in a chemical reaction. You can see here how many moles of H2O are produced from a reaction of 2 moles of hydrogen. And it's the coefficients here that are really key. I put them in red. If you don't see a number here, you assume it's 1. So to answer this question, how many moles of H2O are produced from a reaction of 2 moles of hydrogen, we can look at the coefficients here and here. We have 2 moles of H2 to 2 moles of H2O. So you might ask yourself, how many moles of O2 are required to produce 4 moles of H2O? So here we need the relationship, the ratio of O2 to H2O. So let's look up here. I'll use another color here. Here's O2. The coefficient here is 1. Remember, if we don't see a number, it's 1. And the coefficient here is 2. So we have 1 mole of oxygen to 2 moles of H2O. But usually we put what we want on top, so we could write it 2 moles of H2O to 1 mole of O2. And if we want 4 moles of H2O, I'm going to erase this to make a little bit more room here. If we want 4 moles of H2O, we have to multiply by 2, because 2 times 2 equals 4. And if we multiply the top by 2, we have to multiply the bottom by 2. That's just math to keep the same ratio. So that would give us 4 moles of H2O and 2 moles of oxygen. So we've answered our question there. How many moles of oxygen in this question? And that's just using the molar ratio. That's just looking at the coefficients in our balanced equation. So here's a mole to mole problem where we're looking at how many moles of this produce how many moles of something else. In this particular problem, it's how many moles of H2 react completely with oxygen, or 4.2 moles of H2 react completely with oxygen. How many moles of O2 are needed? So first of all, let's start with what we have. 4.2 moles of H2 and figure out what we need. We need to know how many moles of oxygen we need. So we know that if what we have is H2, that's what we want to put on the bottom. So we look at how many moles of H2, 2 moles H2, to how many moles of oxygen, 1 mole of O2, and then these cancel here, and we're left just to do the math because we have the unit we want right here. So the math is 4.2 times 1 divided by 2. And you'll see that when you put that in your calculator, or you can do it in your head, that's 2.1. So we need 2.1 moles of O2. It's just, again, we just looked at those coefficients in the balanced equation. So let's take, sometimes we need to go between grams and moles, and so let's take a second to think about molar mass. Molar mass is how many grams 1 mole of an element or compound weighs. You can look on the periodic table to figure out the atomic mass. Should be atomic mass. So if we want to find the molar mass for calcium bromide, we need to add the mass of calcium, which is 4.08 grams. I got that from the atomic mass on the periodic table. And then we need to add the atomic mass of bromine. And we need to do that twice. We need 2 bromines. So 2 times 79.90. And you may want to multiply through here before you add, or you can just do it in your calculator and put a parentheses here. So when I'm working on my calculator here, 2 times 79.90 equals 159.8. And then I can add 40.08 to that to get my final result, which equals 199.88 grams per mole for calcium bromide. So all I did is, this is calcium and this is bromide. And remember, we multiplied bromide times 2 because there's 2 bromine atoms in calcium bromide. So that's the molar mass. That's how many grams are in 1 mole of a compound. And it can be 1 mole of an element if you're just working with an element, like if it was just calcium, you'd look right here. If it was just bromine, this would be the molar mass, but if it's a compound, you have to add up all the elements in the compound. So here's another mole-to-mole problem. How many moles of iron oxide will be produced from the reaction of 1.5 moles of iron with oxygen? So we're assuming here oxygen is in excess, which it usually is if you're working in air. So here's the balanced equation. Look for those coefficients. We'll make them pink. And solve by putting what you know. We put the 1.5 moles first because that's what we know. And then we put the molar ratio. We look for the moles of iron oxide. That's what's right here. So we put that here. And this is what we want, so we put that on top. And what we want to cancel out is the iron. So we find the coefficient on iron and we put that here. So we have 2 moles of iron oxide for 4 moles of iron. We cancel the moles of iron here because that's not the answer, that's not the unit we want our answer in. And then we just have to do the math. I'll circle the numbers we're going to multiply and divide here. So it's 1.5 times 2 divided by 4. And we know 1.5 times 2 is 3. So it's 3 divided by 4, so that equals 0.75. Hopefully that wasn't too scary. We just got our molar ratio. We just looked right here at the balanced equation. So let's use grams. We have an unbalanced equation here, and we want to react 4 grams of aluminum, this is what we have, with excess aluminum oxide, or excuse me, iron oxide. How many moles of iron will be produced? Well, our first step is to balance the equation. And we know that we're going to need some more aluminum, and we're going to need some more iron. That looks pretty good. I balance it on the next page. Let's see if I did a good job. There we go. So there's the balanced equation. Now what do? Well, we start with grams of aluminum. And what do we always do if we have grams and we don't know what to do? If you're thinking convert to moles, you're thinking the right thing. So we start with 4 grams of aluminum, and we want to convert that to moles. So we need to figure out how many grams of aluminum are in 1 mole of aluminum. So down here we have the molar mass of aluminum from the periodic table. This is just, remember, the atomic mass of aluminum. It's the bigger number. If you look on the periodic table on the bottom, pick the bigger number on under the Al symbol, you'll see 26.98. So that cancels out the grams of aluminum here. And so far we're now in moles of aluminum. Now we need to take the moles of aluminum and convert to the moles of iron. So here's where we use our molar ratio. So we put moles of aluminum on the bottom because that's not what we want our answer in. And we want our answer in moles of iron. So here's the coefficient on iron. So the molar ratio is 2 moles of aluminum here to 2 moles of iron. It's just a 1-to-1. We could write this as 1 and 1 if we wanted to. Now, if we just wanted our original answer in moles of iron. So that's where we are right now. We've canceled out moles of aluminum, and you notice that the only unit left is what we wanted our answer in. We wanted our answer in moles of iron. So now we can just do the math. It's going to be 4 times 1 times 2 divided by 26.91 times 2. And these really cancel each other out. So it's really 4 divided by 26.91, which gives us 0.14. We'll go 3 places here, moles of iron, which is pretty small, but we only started with 4 grams of aluminum, which is a tiny bit of aluminum, so that's about right. If we wanted to convert our answer from moles of iron into grams of iron, we could go 1 step further. Let's walk through here. We would use the grams of aluminum, convert that to moles of aluminum, convert the moles of aluminum to moles of iron, and then go back into grams of iron. And this is just the molar mass of iron right here. Lots of things would cancel, and our answer would be in grams of iron. That is if we wanted to take it 1 step further and go to grams of iron. Here's a mole mass problem. We'll just get this one started, and I'll set it up for you. We have moles of silver nitrate, and we need